Welcome to the IMC YouTube channel. Maharashtra SET exam 2021 question and answer paper 2 chemical science. Question number 16. The operational, personal and instrumental errors are of types determinate, indeterminate, additive and proportional error. In the error you have two types of error, major type. One is a determinate error and another one is a indeterminate error. These three types of error, operational error, personal error and instrumental error, comes under the category of determinate error. So option A is the correct answer. Question number 17. The kinetics of isomerization of cis and trans complex has been given by IR spectra. Which of the following region for IR spectrum you will get? Let us draw the structure of this complex. Here, this is cis form. This is a cis compound having C2V point group. For trans compound, you will have MO. So this is a trans compound having point group D4H. So these two compound, among these two compound, IR band shows 9 bands will get for a cis compound and you will get 1 IR band for trans compound. The terminal carbonyl shows in the range of 2100 to 18,850 centimeter. This was the range. So in the given option B is the correct answer. Question number 18. In the base catalyzed substitution of Cl by OH in the given complex under strong basic condition, the first step in the mechanism will be. First let us take the complex, that is chloro pentamine cobalt 2 ion. For this complex, if you substitute with OH minus, hydrogen will be abstracted from this NH3 group. One hydrogen will be abstracted and the water molecule will be removed. So you will get, it's an amido group. This amido group is an conjugate base. Here substitution of Cl by OH, no, it was wrong. Dissociation of Cl to give 5 coordinated complex, this option is also wrong. Association of OH to give 7 coordinated, no, 7 coordinated was not formed. The conversion of amine ligand to amido ligand. Here you see this is an amine ligand is converted into amido ligand. Option D is the correct answer. Question number 19. The crystal field stabilization energy in an octahedral Ti3 complex is given 2100 centimeter inverse. Crystal field for its tetrahedral complex they are asking. Here we know the relation. Here for tetrahedral complex crystal field stabilization energy has been given. For tetrahedral complex they are asking. Okay, there is a relation where delta T is equal to 4 by 9 delta O. This is the relation. So 4 by 9 into 2100 centimeter inverse, you will get 8933 centimeter inverse, and option C is the correct answer. Question number 20. The reactant PTCl4 has been given with NH3 reaction type 1 and PTCl4 with reaction NO2 minus reaction type 2 followed by NH3. So what will be the mechanism? And what is the way of forming? They are given 4 options. We will see in detail. Let us take the complex. PTCl 2-. When this treated with ammonia, one chlorine will be replaced with ammonia. Again, you add another ammonia. Listen here. This ammonia has a less trans effect. Now this ammonia can be substituted here or here. So which is the substitution of ammonia? Here the ammonia is substituted not to the trans side. You will get the compound. You will get the cis compound, not the trans compound. Not trans. You have to remember here, trans compound will not be formed, only cis compound will be formed. This is reaction type 1. Because this ammonia is more labile, it's a more labile complex, hence cis compound is only formed. Let us take the reaction, this is reaction type 1, and let us take the reaction type 2. Let us take the complex. Here it is minus, it's not 2-. Here it is 2-. First you substitute NO2 minus, here it is minus. Now you substitute ammonia NH3. Now it is having a greatest trans effect NO2 and Cl. So this ammonia is substituted trans to the NO2, and you will get a trans compound instead of cis compound. A trans compound is formed. So here in trans effect, you have to remember the trans effect. That is, the ligand NO2 minus has a greater trans effect than chlorine than ammonia. The C is the correct answer. In reaction type 1, cis compound is formed. Reaction type 2, trans compound is formed. Question number 21. SF4 reacts with BF3 to form the complex. F19 NMR of anion will exhibit. Let us take SF4 plus BF3. This gives the complex. SF3, this is a cation, and BF4 is a anion. Now they are asking for anion, this BF4 minus. That's a B19 NMR spectrum. Let us take this BF4 complex. This BF4 is a tetrahedral complex with having sp3 hybridization. F19 NMR. For this complex, you will get 2Ni plus 1 signal. That is 2 into 1 into I value for F is 3/2 plus 1, which is equal to 4, which is a quartet. Because these 4 ligands are same, the quartet will not follow Pascal's triangle. So this quartet will be 1:1:1:1. It is not 1:3:3:1. This is Pascal triangle. You will not follow Pascal triangle. You will get 1:1:1:1. Hence, option here 5 equally spaced. No, it is wrong. A quartet with intensity 1:3:3:1. No, the quartet is formed, but the Pascal triangle was not formed. This quintet is not formed. Option C is wrong. 4 equally spaced lines with equal intensity. That is 1:1:1:1. Option D is correct. A quartet with 4 equal intensity. Question number 22. Which statement about trans effect and trans influence is correct? Trans effect is a ground state effect, whereas trans influence is an excited state effect. No, this option is wrong. This was reverse. Both trans effect and trans influence are ground state. No. Here you see a trans effect. Trans effect is a ground state effect, whereas trans influence is a excited state. So rate of substitution effect in trans effect, this was also wrong. Trans effect is a ground state effect, whereas trans influence is a excited state effect. Option D is the correct answer. Question number 23. Oxidizing tendency of chlorine in oxo anion. They have given the oxo anion. Listen. In ClO4 minus, calculate the oxidation state. ClO4 minus, let us take the chlorine as oxidation state X. Oxygen, it is minus 2 into 4 equal to minus 1. So X equal to minus 8, X minus 8 minus 1, X equal to plus 7. Similarly, for ClO3 minus, it is X minus 2 into 3 equal to minus 1, X equal to plus, it is a plus 5. For ClO2 minus, you will get oxidation state plus 3. For ClO minus, you will get oxidation state plus 1. So as the oxidation state increases, is plus 7, for this is a plus 5, is plus 3, for plus 1. Oxidation state increases, the oxidizing tendency also increases. ClO4 minus has more tendency of oxidizing power than ClO minus. Hence, here option B is correct. ClO4 greater than ClO3, greater than ClO2, greater than ClO minus. It is the least oxidizing power. It is having a most oxidizing power. Question number 24. Keeping all the parameters the same, if the standard deviation is doubled, variance would be. You have to remember the relation between variance and standard deviation. Variance is the square root of standard deviation. V equal to sigma square. Here the standard deviation is doubled, hence 2 square, which is 4. Hence the answer is quadrupled. It is 4 times. The molecular geometry of XeOF5 minus is. Let us take this xenon. You know, this xenon having 8 outermost electron. 1, 2, 3, 4, 5, 6, 7, 8. And also here 1 electron, this one minus charge. You add another one minus charge for another electron. So 9 electron, 9 outermost electron here. So there are 5 fluorine atom. 1, 2, 3. You substitute 5 fluorine atom here, and 2 electron for oxygen atom, and 1 lone pair. So this XeOF5 contains 6 bond pair and 1 lone pair. So totally 7 pairs. For 7 pairs, the hybridization will be sp3d3. sp3d3 hybridization shows pentagonal bipyramidal. Pentagonal bipyramidal. But here the pentagonal bipyramidal, here you have 1 lone pair of electron. This XeO5 has 1 lone pair of electron here. So this lone pair bond pair repulsion, due to lone pair and bond pair repulsion, this pentagonal bipyramidal structure will arranges to, it shows pentagonal pyramidal structure, not pentagonal bipyramidal structure. Hence here option B is the correct answer. Pentagonal pyramid. It's not a square pyramid. Square pyramid is not formed. Octahedral structure is not formed. And trigonal bipyramidal is if you have 5 bond pair, if you have 5 pairs, you will get trigonal bipyramid structure. Here the hybridization is sp3d3, hence it is a pentagonal pyramidal structure. Question number 26. The only metal which forms nitride M3N among the group: potassium, lithium, sodium and rubidium. Lithium, due to smaller in size, it forms lithium plus nitrogen gives Li3N. The metal formed by L3N, this rubidium, this forms not M3N, it forms RbN3. Hence option lithium is correct. This lithium having a more lattice energy, and due to smaller in size, lithium forms a metal nitride. Among the tetrahedral complex of cobalt has been given, 3 complexes given. The complex which shows optical isomers is, we know that the tetrahedral complex does not show optical activity, but the only complex which shows optical activity is metal ligand ABCD. This complex only shows, tetrahedral complex only shows optical activity, that is ABCD. 4 different, the metal atom attached to 4 different type of ligand. In given option, you see this complex which contains 2 bromine ligand, 2 chlorine ligand will not show optical activity. In option 2, it contains 1 bromine, 2 Cl ligand, it does not show optical activity, whereas in option 3, cobalt is attached to bromine, iodine, OH2 and Cl, which was in the type MABCD, having 4 different type of ligand. This shows optical activity. This tetrahedral complex shows optical activity. Hence option here D is the correct answer. 3 only. Question number 28. The rate law for the substitution in square planar platinum complex containing 2 terms. Rate equal to K1 PtL3, here L3X and Y. The starting compound and Y is the entering compound. The reason for the 2 term is due to the solvent enters. This is due to the solvent effect. The solvent enter into the rate determining step and then 2 competing fast step follows. Option C is the correct answer. This is due to the solvent effect. Question number 29. The symmetry elements in the compound having a tetrahedral shape with the sp3 hybridization. This shows the point group CS point group, because there are having a 4 different ligand is substituted to this silicon. You will have CS point group having only 2 symmetry elements E and C1. Option B is correct. Question number 30. Ground state Mulliken symbol for central metal ion, this FeCl4 2- is. In this central metal ion, Fe shows Fe2+ oxidation. For Fe2+ is a Fe2+, it is a weak field, it's a weak ligand. Cl is a weak ligand which shows 3D, it's a I spin complex. You will have, this is T2G, this is Eg. This is for octahedral complex. They are asking for this, you will have the diagram is a D5 configuration, multiplicity is 5. For octahedral complex, it is T2G ground state and Eg excited state. T2G is the ground state and Eg is the excited state. For octahedral complex, but they are given, they are asking for tetrahedral complex. It is a tetrahedral complex. For tetrahedral complex, you will have T2G here, EG here. For tetrahedral complex, you will have E and T2. You remember, here the G will not come. Here only E and T2. Here it is 5, 5. T2G5, EG5. Now E5 is the ground state, T25 is the excited state. They are asking the Mulliken symbol. This is a Mulliken symbol for the ground state term for tetrahedral complex. It is E5. It is E5. Option C is correct. D5 is not the ground state symbol. They are asking Mulliken symbol, not the term symbol. This is the term symbol. This was not correct. And EG5, this is for octahedral complex. It's a excited state for octahedral complex. Given is tetrahedral complex. And S6 is not related to this question. Option D is wrong. Option C is correct answer. I hope this video is helpful for you. We will meet in the next video, part 3. Thank you for watching. Thank you.